Fail fast. You probably saw this sentence many times in the past. In the world of constant innovation, fast feedback loops, and beta versions everywhere, for many companies, the key is how fast they can fail, learn, and recover. And everyone important talks about failing. Einstein once said, anyone who has never made a mistake has never tried anything new. My name is Mirek. I am the tech lead for apps and R&D at Azimo. And I will tell you the story how to build the environment that is fail-friendly so the company can try as many things as it is possible. My responsibility as a tech lead is to be a kind of translator between the engineering and the business. And this is what I have learned so far. When business repeat their mantra, fail fast, fail often, fail better, succeed, it actually means ship fast, iterate often, don't crash, and succeed. And how to measure the success, you can ask. And I will tell you as a manager, by KPIs, or key performance indicators. In our mobile team, they are simple. So we want to have a crash-free rate, crash-free user rate, higher than 99.5 every time. And we want to be able to release once a week. And if someone asked me about releasing once a week about 2 or 3 years ago, I would say it is not possible, because actually this is how much time we needed to do entire QA manual testing session. Back then, we were releasing about once a month. And the process usually looked like this. So in week 1, software engineers, they were doing the code. And the business and the QA, they were doing something completely different. In week 2, software engineers continue their work on the features, and the QA and business, they are checking the version which was shared with them in the first week, and they are giving the feedback. So in week 3, software engineers are doing fixes and amendments for the version from week 1, and the QA and business, they are checking the version which was shared with them in week 2. And moving on, in week 4, final fixes and amendments, and we can go live. As a contrary, this is how we work today. So assuming that we have the same amount of features to develop, we are going to release, let's say, 3 versions instead of 1. And again, the process. So in week 1, developers are working on features, but every time when something is done, it is immediately exposed to QA and business. So it also means that they are giving us immediate feedback to the features which we are developing. So moving on, in week 2, we are able to push the release candidate, and we are able to go live. So we can even start working on the version 2. And the same pattern for week 3. So we are going with version 2 live. And the same pattern for week 4. So we are live with version 3. And they took us the same amount of time. So the question is why it's better to release more often. First thing, the big difference is in how many things engineering team needs to keep in mind. Because, for example, if you are working on the feature 8, and you get feedback for feature 1 or feature 2, you need to remind yourself what you were working on about, let's say, 3 weeks ago. Also, we all make mistakes. Yes? So when you have big releases, there are a lot of things that can go wrong on production. And with big releases, business needs to wait to gather market feedback until when everything is done. So with small ones, business can start learning from the market from version 1 in the same time when you're working on version 2 or version 3. So what we should do to ship fast, first of all, we need to identify and understand the delivery process. And in most cases, it looks like this. So we have a coding phase, we have a testing and reviewing, and we are going live. But usually, what is the most important is written between lines. So for example, in our case, after coding and before we started testing, we had some additional steps like writing down the what's new section. We need to share the version with the company. So what, in our case, at the very beginning, it was just sending the email with APK file to some people in the company. So you need to write the email. You need to, of course, bundle the APK. So probably this happening on your own computer. And probably a couple more other things like, for example, importing new resources or translations and so on and so on. And the same with release candidate distribution. So again, you need to write down the release notes. Probably you need to write the what's new section, plus you need to push screenshots to the store. So a lot of steps, which at the beginning probably you do manually. But now when at least you have the clear situation and you know what exactly is happening between all those steps, you can start measuring things. And you can even start doing this in the easiest way. So just launch your stopwatch and see how much of your time is needed after you finalize the coding and before, for example, QA team can start testing the app. And this is our situation about 2 years ago. So we had a couple hours for internal distribution, a couple hours for release candidate distribution. We had some feedback loops between QA and the engineering team, and about 1, maybe 2 days for QA manual testing. So if you think about releasing once a week, as you can see, there is not much time left for coding. That's why we needed to start our optimization process. And first, we need to start with the most tedious things, so the building and the distribution. And it is always very important to identify every single step in your process, because it will be much easier for you to automate this in the future. So when you have all commands written down, all you need to do to start building your continuous integration, for example, will be just copying and pasting the list of your commands. And the building and distribution is, of course, the simplest thing. Because when you start automation, there will be more things which are tedious for you and what you would like to have automated. So for example, the simpler things, in our case, every time when we push new version to our repository, there is new merge request created automatically for you, and it's assigned to the person which isn't you. So it saves us about 4 clicks. And another one, every time when we want to push build new release candidate, we do automatically incrementing of app version. We create automatically merge request, and there is also a release candidate distribute to the people in the company. And in this situation, we save about 10 clicks and 3 additional lines of code which are written automatically for you. And there will be more sophisticated automations, like in our case, it's nightly testing. So in our CI, every 24 hours, we launch automatic testing process, which runs the emulators, which do the configuration, which sets things like the language, but also the permissions. Then we run all tests, I mean the functional and the end-to-end. And we generate HTML file with the report from the testing. And we put this information to Slack. So every time when we start the work, this is what is waiting for us on the Slack channel at the very beginning. And another automation, this is automatic translation update. So every 24 hours, we fetch translations from our translations API, which then are put automatically into res values directory by our Python scripts. And then we assemble APK and run linter. So again, when you start your work, this is merge request waiting for you just to be merged with the new translations. And there are many ways of building automations. We use Gradle plugins like the Fabric for release candidate distribution. And there is also a plugin for distributing APK to the Play Store together with the screenshots and the what's new section. For more complex things, we use the Python scripts, so for things like the translations, for example. And we also use declarative pipelines from Jenkins to automate bash scripts, for example. And yeah, when we have satisfying automation for our release process, what's the goal now? We would like to minimize testing time and the number of loops between software engineers and the QA engineers. And to do this, we redefined the quality assurance process. And rule number 1, key feature can be tested manually only once. And with that in mind, we created 3 stages of quality assurance. It's the development phase, so it's just the checking the code with the unit test and with lint. There is fast feedback QA, and this is the only stage where our QA engineers are testing our app manually. And in this time, they are also adjusting their testing infrastructure to the new features or new flows which came with the new version. And there is last phase, which is release candidate testing, where we run all end-to-end and automations and functional tests. Yeah, and starting from the beginning, lint checks, if you don't use them, there are tens or hundreds of different code checks which give us informations like missing translations or maybe different number of arguments in those translations. They tell us about using the methods which aren't supported on older Android versions, and maybe about the most common mistakes we make in our UI interface. And there is absolutely no reason for not using them. So if you don't, launching them should be very first thing on Monday morning when you get back to job. Next thing, unit tests. They are written by software engineers, and they test single unit logic. So usually it's a single class logic. And they should be always available to launch in seconds. And before our app is passed to QA engineers, all unit tests must be passing, always. So why they are so important? Imagine the simple example. So we need to validate that we are showing the rating box in the app. So you need to launch the app. You need to go through the flows, and you need to find the screen. And actually, to make these screenshots, I needed more than 3 minutes to reproduce all flows and to see this pop-up. And here on the left, you can see the simple presenter test, which do unit tests checking this in less than 1 second. And another 2 example unit tests that are checking the criteria behind showing this rating box. And you can go into details as deep as you want. But the question is, should we try to reach 100% tests, 100% code coverage by unit tests? Well, if you want to check the simple method calls or maybe constructors or maybe getters and setters, why not? But I think that they taking this job too serious isn't also anything good, because at the end, unit tests don't give us full answers about the product correctness. So instead of 100% code coverage, our standard is to have about 50 to 60% lines of code covered by unit tests. And thanks to this, we can pass our app to the QA engineering team a little bit faster. Yeah, and next step, so integration testing. Those tests are built by our QA engineers, and they are run on the emulators or the real devices. And each integration test is run on hermetic environment. So what does it mean, the hermetic environment? If we take a single screen of the app, it is usually composed from three things. So it's data, it can be API, it can be database. Those are user settings or maybe device settings. There is also domain, so use cases and presentation logic, and of course layout. In integration tests, data and settings are mocked and or provided as an initial config for each integration test. And what is tested is our domain and the presentation logic and layout. And thanks to integration tests, we can, for example, test all possible cases or possible states of our screen. So in our situation, we have a screen which has, I think, more than 20 or even 30 different states. I mean, different UI components, different background and copies, and different logic for some things. And in practice, single test template is composed from a couple things. First is a virtual device manager, and it is responsible not only for launching the emulator, but it also does things like the initial configuration. So for example, we grant or we get the permissions, we set the language, and we set the things like, for example, screen size, and so on and so on. Then when the simulator is ready, there is a mocking phase. So in most cases, when it comes to data mocking, we have hard-coded JSON files. And for mocking objects, we use Dagger mock and the Mockito. And there is also one more step. It's initial state activity. And this is the hidden screen, which is launched before the real test, the integration test is launched. And we use this hidden activity for configuration, for example, for setting things like the short preferences or for warming up some classes. And then we launch our integration test. And here you can see example of integration test. This is a very simple case that is checking that we are showing the pop-up or the screen asking user for updating the app. And besides the virtual device step, which is configured by our Python scripts, here you can see the remaining three phases of the integration test. So there is a mocking, init state activity, and there is the real test. And yeah, when integration tests are done, the last phase of QA is end-to-end testing. And those tests simulate end user. So there is no mocks. Our application is tested in exactly the same way like user would do this. So it goes through all screens. So it's the login phase and other flows. And those tests don't only check the app correctness, but actually entire platform integrity, because there are API calls and so on and so on. And the only problem with end-to-end tests is that they are really time-consuming. So one of examples in our situation is about inviting people. It means that our test needs to log into to user one. We need to send the invitation. Then we need to log into the user two to get this invitation. And then we need to log into the user one to see that the invitation was accepted. It means that this test takes about 2 minutes. And to have the clear boundaries, we said that our end-to-end tests cannot take more than 2 hours all. And this is how the functional and end-to-end testing looks like in practice. So we have the TV hanging in our room. And here you can see 3 simulators with different configuration which are going through all integration and end-to-end test. And you can say that this testing framework or the process is really complex, and it is. Actually, this is such a big thing that it cannot be developed at once. And for sure, there will be no boss or product manager telling you that, yes, right now you have 3 months of time just to build testing framework. Especially if you work in a small team, this should be the duty for everyone to be 1% better during every release, because otherwise we won't be able to build such a complex thing. And this is our roadmap for QA automation. So at the very beginning, we had no single unit test, but almost 1 year later, we had about 40% code coverage for unit test, and we started QA engineering. So today, like I said, about 50 to 60% of lines of code is covered by unit test, and all features are covered by integration or end-to-end test. And in some day, we just had the single ticket called Lean Zero project. And it took about 2 or 3 days where we were removing all warnings by fixing them, all lean warnings by fixing them, or by ignoring them, because of course we cannot make our app so perfect. And also, as a result of our QA automation process, we published 2 open source projects. And first is called Automation Test Supervisor, and this is our platform to run integration and end-to-end tests. And it handles things like the emulator launching and configuration. It also prints reports from those tests. When it comes to flakiness, this framework also gives us possibility to rerun failing tests, so we are sure that they are the real failing tests, but not, for example, the flaky ones which were caused by poor internet connection, for example. And in the past, we were using Fastlane for the automation, so we created another plugin for Fastlane, which was responsible just for running the emulator and configuring it. Yeah, so right now, when our delivery process is optimized enough for us, we can focus on the thing which matters the most for us, what is coding. So we have a couple principles for the way how we write our code. First, write the code that matters to you, that matters to your company. We assume that everything what isn't related to your business probably can be generated for you. And another one, stay away from SDK. So it's about proper abstraction of the code. And the last thing, your code must be testable. Because if it isn't, this is probably the bug, either in your code or in the task specification. And what does it mean that code must be easy to test? This is our first approach, all-in-one classes. So we had huge activities which were doing everything. So the UI logic, but they were working with data, networking, navigation, everything. Is it testable? No, it is not. Maybe we could test it via end-to-end testing. So you start splitting things into patterns like model, view, presenter. And is it testable now? More or less it is, but it isn't easy because usually at the beginning you are just moving your activity code to the presenter, which now is responsible for everything. So the testing those presenters is also painful because usually you have more than 10 different dependencies which you need to mock during every single test. And also this pattern, this design pattern, doesn't assume for example, how to deal with things like Android SDK, so like resources or strings and so on and so on, and how to deal with threading, for example. And working with Android resources is also really slow, because when you add, for example, a Roboelectric framework, some classes, in our case, needed about 2 or 3 seconds just to warm up this testing framework. So at the end, we ended with something like this. So right now, everything in our code has clear, separate place. So we have view logic, so it's the view part. We have domain, which is use cases, and we have data, so the repositories, managers, and data stores like databases, API, and so on and so on. Is it testable now? Yes, it is. So when we are testing, for example, Navigator, we are focusing just on navigation features. And the same with view logic and with our domain or use cases. And if you want to test the integration, you just mock the data part, and you are checking the interface and the domain. And end-to-end testing is always easy, but like I said, it's also time-consuming. But this separation isn't only about testing. So this architecture also helps us with focusing on things like the threading. So we know which components should be run on UI thread, which components should be run on background thread, and we know what are components which ensure that proper thread was picked. And there is also only a couple places where we use Android SDK things like the resources or strings and so on and so on. And the rest of code, the most important that is tested, is just the pure Java or Kotlin code. So it should be runnable really, really fast. And you can ask, what is the best architecture pattern for you? And I think there is no single answer for that. So I would say the one that makes the developers team the most productive. And also yesterday there was a great talk by John Sandel telling how to build your own architecture. So I encourage you to check when it will be available on the YouTube. In our case, we started with architectural pattern model view presenter. But I think that today we are closer to MVVM after the adjustments for our needs. And if you have no idea how to start, I highly recommend checking this repository called Android Architecture Blueprints. It's, there are a lot of different cases of how to build the code architecture, so for sure you will find something for you. And when you pick the best pattern for you, the last thing you need to focus on is the writing logic that matters to you. So the rest code could be generated. What does it mean? Simple example, butter knife. So you know how it works. It injects all resources like strings, like the dimensions, colors, and so on and so on. Thanks to butter knife, you can focus on the logic that matters, and only this. Without butter knife, our code is a mix of a little bit of initialization and a little bit of logic. So, you know. And the same with Dagger. So if all dependencies are provided for you, instead of you don't have to struggle with finding the way to provide the most hidden dependency to your activity code. And of course, Dagger isn't only about providing dependencies to your activity code. So thanks to features like multi-binding, this is how the view adapter code looks like. That is handling more than 10 different types of views in our code. And actually, I think that the create view holder also can be removed from here, because it is written in the class that we are extending. Yeah, so thanks to things like the multi-binding and, for example, the connection with Autofactory, you can provide not only objects, but actually the factories of objects that are created on demand. And this is how the module that is providing those features look like. And in case you are curious, this is the view holder for the mentioned adapter. And for more, you can check my GitHub account. There are a couple projects or examples showing how to work with Dagger, how to inject things asynchronously, how to use multi-binding and autofactory. And there are also some demo apps showing how to use this in, let's say, a real project. And when it comes to code generation, there is also our newest open source project for API error handling. So if you struggle with things similar to this, you should check our GitHub account, because now all you have to do to deal with errors from the API is just defining the interface for how we should handle each error in our view. And what else you can do to make your coding more convenient? You can split it into modules. So when you start working with dependency injection framework like Dagger, you will bundle dependencies into some modules. And very often, at the beginning, we build modules which are split by class dependency, by class responsibilities. So, for example, we have data module with all classes connected to working with data, and the API module, and there is, of course, utils module for everything else what doesn't fit into other modules. And at the beginning, our object graph looked like this. So it's pretty simple, and the same with API-related classes, so it's really readable. But in reality, over the time, such general modules like data or API grow bigger and bigger. And here you can see our data module, which now has more than 600 lines of code, so probably more than 200 different dependencies connected to data. That's why sooner or later, we need to think about modules that are split by product features. So in our case, we have modules for the payment, for the cards management, and so on and so on. And each module has all required dependencies to build this functionality. So those are API clients, but also database managers, domain logic, and so on and so on. And this split is especially helpful if you are working on your project in a bigger team, because instead of everyone committing into, for example, data module, you can work simultaneously on different modules in the same time. The only problem is that over the time, list of modules become bigger and bigger. And actually, the code you see here is just the 1/3 of our entire object graph. And this is the photo I made about half a year ago. Another problem, because it isn't actually fake. So my colleague Dominic tried to work on the code on 2 laptops. And why is that? Because our code base was so big that when the code was compiling on the first computer, Dominic could working on the second laptop to make the code for another features. And the only way to fix this is to split our project even more. And this is why we built our current architecture. So we not only have separate Dagger modules, but actually entire code base was split into project features, which right now are developed and even compiled and tested independently. So if you have worked with microservices, this is what we are trying to achieve here in the mobile app. And so far, there are a lot of advantages of this approach. So like I said, the features can be quickly compiled and tested. Architecture, it's a bit cleaner. But there are also some disadvantages. So when we are working, when the working on the feature is now more convenient, working with entire projects, it's a bit harder because you need to understand how to connect those dependencies with each other. You need to handle 10 different Gradle files that are configuring them. And what means that the entry level is really big, especially for less experienced software engineers. And because those solutions aren't very popular yet, there are still some unanswered questions. For example, how to build Dagger graph for multi-feature app. And the biggest problem, the migration to the new infrastructure isn't easy. And actually, this is the reality of our code base right now. So I would say that we have about 50% of our code rewritten to the new infrastructure. So if you want to give a try to project modularization, I have created a small project on my GitHub where you can see things like this multi-module setup, how to structure, for example, Gradle files, how to build Dagger across modules. And this is my proposition of way of working with Dagger, because in the internet you will find at least 3 different approaches for how to work with Dagger. And how to make unit testing easy for entire app, but also separately for each module, how to build test coverage, and soon probably a couple of things more like integration tests, but also ProGuard configuration. So just visit my GitHub account, and also I will be really grateful for your feedback and contribution to this project. And there is also one last thing I would like to talk about quickly, because I was talking mostly about technical aspects of delivering or building our product. But actually, building the product isn't only about automation and testing and even coding, because this is also about the people who are working on this product. And at the beginning of my presentation, I was talking about KPIs for our mobile team. And actually, one of them is more important than the other. Crash-free users rate is our ultimate goal. And to keep it, we introduced very important rule in the way how we work. It is called Stop the Line. And it was invented by the Toyota in 60s or 70s. And this rule says, every employee on the assembly line has a responsibility to push a big red button that stops everything whenever they notice a defect. And it means that no matter if you are leading architect or the software engineer or QA engineer or designer, you have full right to stop the release process when you find a bug. And in your opinion, it is important to fix this before we go live to production. And for more than a year now, we have no fixed release days in our company, because our app is released to production only when it's ready to go there. So with that in mind, in the last 12 months, we released about 40 new app versions to the store. So what does it mean to our KPIs? The most important goal, so crash-free rate, was achieved in 100%. And we achieved more than 80% for the second goal, so it isn't a big price for our customers' satisfaction. And guess what? Usually, users don't know what and when you are going to release. So really, if the feature isn't RODO or GDPR related, in most cases, it doesn't have a hard deadline. So for the rule, Stop the Line. This is the slide I saw on on the conference or YouTube talk, YouTube video, and this is the last thing I would like to leave it to you. That's it. This presentation will be posted to my Twitter after this presentation. Thank you very much. So, any questions?
Is there an iOS version developed in parallel to this one?
Yes.
And how close are these two projects together? Do you synchronize your quality assurance test cases? And
you're asking about similarity of the process, or? So
also, but maybe mostly about how you synchronize that the two apps somehow are the same, or maybe they don't have to.
Yeah, so It depends on the company requirements. So if it is possible to go live on the, one platform, we prefer to do this in this way because we can validate, for example, the features on the Android, and then we can, let's say, backport them to the iOS. But usually, the gap between those platforms is about, I think, 2 weeks, something like this. So we try to be parallel enough when it comes to delivering things.
And are there people who work on both of these projects, like QA engineers or?
So we assume that everyone in the team has basic skills to do everything. So a little bit of coding, but also a little bit of QA. But when it comes to more complex things like the engineering of, for example, testing infrastructure, we have one QA engineer doing work for iOS and one QA engineer doing work for Android. And we try to have, let's say, similar architectural patterns between Android and iOS, but of course we write them completely independent.
Okay, thank you.
Thanks. Okay, any other questions?
Hi, I have a question for the device testing on emulator. Do you have any suggestions for the cloud-based solutions that you use, or I mean, to cover all the possible, screen resolutions on the Android, especially?
Yeah, so we decided to build automation on our side. So the hardware is in our room. We have CI dedicated computer in our room because especially when it comes to Android, we needed to write entire testing platform or framework from scratch because at the beginning the official solution weren't stable enough. So we had the flakiness and crashing simulators and so on and so on. That's why we decided to write our own test and infrastructure. But right now, yes, we are looking at possible solutions for cloud testing. We are looking at Fire-based test lab and also AWS device farm. But this is our plan for next, let's say, half a year. Because we are still dealing with the complexity of device management on our side. We are not sure if we want to do this for the long time. But at least right now we can fully understand what is happening. So I'm not sure if this answers your question.
Yeah, I think that's okay. Thanks.
So hi, I really like your modular architecture, but I've got one question. So, as I understand, each feature has its own module.
Yep.
But what about the common objects like date formatters or input formatters? It's really tempting that all these common objects are in one big module, and this module is linked to the each feature module. So how do you handle it? Do you implement like the same object in each module, or you've got one big module with common things?
So we have a split for the feature modules, which have not only the code, the Java code, but also the resources and the layouts and so on and so on. This is one layer. And another layer is the shared features module. And those are also split into modules. Like here, we can have shared features for the countries or currencies, which are just the Java code. And those features are shared with the product features. So we try to not duplicate the code. We try to share this functionality with other features. And there is also a base class where we have the code which is used everywhere. So like you said, the formatters or, for example, HTTP client, at least builder, is provided in the base class. So this is how it looks like right now. You know, the truth is that it is not possible to build 100% clean architecture. So I would say that this architecture is for about 90% of the code, and the rest are just edge cases which you need to try to squeeze somewhere. Cool. I think that there are no more questions. So yeah, thank you very much.